We have one more over there. Evan, where are you at? Oh, you're there. Okay. All right, I'll go over there. All right. I think most people are set up. If you run into any issues, just at lunch, I'll be here and we can sit down and sort out how to get anything running on anything. But if you do run into any issues and you just want to unblock yourself right now, you can go to snack.expo.io and you can run this code immediately in either this preview thing here, or if you press run on device, you can just sign into your account and then sign in from the app on your phone, and it'll have this editor for you that will just be perfectly sufficient for the exercises that we're doing. All right. And so an example of that is I have this here, right? And now this unnamed snack, which is the thing I just opened, shows up here, and I can open it up, and it connects. And I can make a change here, right, and it just shows up there. So this is just an easy way to do that for now if you're running into any issues. Okay. So this morning, now that we're through with this unfortunate setup phase that seems to happen at a lot of workshops, we can move on to talk about animations. So probably most people are familiar with what an animation is and kind of the concept of video in general and how kind of motion is kind of created, or the sense of motion is created through screens. But just to recap it, because it's very relevant to the topic that we're discussing, obviously, the way that we create a sense of motion is by changing pictures very quickly on a screen. So the phone, an iPhone has a refresh rate of 60 hertz, so it basically changes the picture 60 times per second, and so each of those are called a frame, right? So you aim for 60 frames per second for your animations so that it looks like every time that the screen refreshes that something has updated as you expect. So when something like this happens, right, this thing is moving across the screen, then 60 times per second, the position is changed, and this is a crude approximation, but ultimately you see this circle kind of appear in different places, sort of like that, and that's what creates this sense of motion, right? So we can kind of think of that in terms of like progress and kind of a translation value in this case. So if we think of progress from like 0% to 100% complete, so this is like a discrete animation where we start at one point, we end at some other point, and the mapping of progress percentage to translation X, you can say here we start at 0, we end at 500, and you can kind of, you're able to calculate like what the value would be at any point in time just from knowing, in this case, the initial value, the end value, and if you assume that this value changes linearly, as is kind of displayed here with the circles, we can kind of quite easily calculate that halfway through, it's going to be 250 points translated on the x-axis, and we would know that at 25%, can anyone guess what that would be at that point? Yeah, 125, right? So pretty straightforward stuff. So ultimately, it boils down to, oh, there's a typo there. But ultimately, it boils down to just like a simple calculation of like, we have some progress, we multiply it by something, and we end up with this value. So how does this map to React Native now? How do we do this kind of animation? So React Native has this API called Animated. How many people have used Animated before from this group? Okay, so a decent amount of people. How many people here would consider yourselves like you understand it well and you're very confident using it? Anybody? Yeah, sort of. Okay, good. So I'm not entirely wasting a single person's time, hopefully. So that's good. As a side note, it's very difficult to do an intermediate, advanced kind of workshop because when everyone starts out, you kind of know that there are certain things that people have to know, and you can cover the range of topics that you think are most important for beginners. But once you have some amount of experience, everyone kind of goes in different directions. So I'm hoping that the topics that we're covering won't, for most people, be kind of repetitive based on what you know, but it's pretty hard when everyone has different paths of learning. So if you do come across a section that you're very familiar with already, maybe you can just help out the people around you, or feel free to ask us more questions to get more, maybe there's some part of it that you don't fully understand, and we'd be happy to go through that. So this animated API is, it looks something like this. So we can map the idea of progress to something called an animated value. And we'll initialize it at 0, so we're saying that we start at 0% through this animation. And then the translate x, we can interpolate the value from the value of translate x from the progress value. So we say that the progress goes from 0 to 1, and the mapping of that to the translate x is from 0 when progress is 0 to 500 when progress is 1. And so by doing this, we're just establishing what is the relationship between this animated value and this other value that we're actually going to use for different purposes. And we can take that value that we've interpolated from the progress and bind it to the style property on a view component. It's important to note that I'm using an animated.view. If you were to just use a regular view without the animated namespace, it would not work because those components don't know how to bind to animated values, and we'll see some more about that shortly. But this is roughly what this would look like, and this would almost create what we saw in the with the circles. The only other thing that's remaining is that we need to actually start the animation, so we need to take this progress value and tell it to, that we want to animate it from its current value to some other value, which is 1, and give it like a duration. So this is over 1 second. We're going to animate the progress from 0 to 1, and then we start that animation. Right, and so then it gives us that kind of thing. So now let's take this and actually put it in the full context of an app. We import animated from React Native. In this case, I'm setting progress, this animated value, as an instance property on the component. So that means that every time you instantiate a new instance of this component, a new animated value will be initialized on it, and it's available through this.progress. this is something that some people have different opinions about where they would like to keep animated values. Some people put them on state or other places. I personally prefer doing it like this, but you're welcome to put the value wherever you like, as long as some people might, in component did mount, initialize the value there. It's totally fine. It really doesn't matter too much. I prefer it this way because typically you're not doing set state on a value. The way that you're changing an animated value is by using something like this timing function. So you're not going to set state to change this to another thing. And so the value never changes. You're never going to change the progress state value and re-render as a result of it. And so it's not really something that is like tied to the render cycle, which is why I don't really, I don't put it in state typically. There are cases where you might want to do that, but that's very rare. I think I've only done that once. So we instantiate this animated value, and then in component did mount, so we just want to animate this as soon as the component is mounted. We start the animation, and we say we want to animate to 1, like we did before, and pass in a duration of 1 second. And in the render function, we define the interpolation and then bind it to the view. Right? And this part is where we do some styles. So I think everyone's familiar with that. Okay, so because this is kind of like foundational, I just want to repeat it again. Right? We can think of the progress of an animation from 0 to 1, or we could have done 0 to 100. The values that we've chosen for the animated value are just kind of out of convenience here. You can map a lot of animations from like beginning to end, in which case it just really doesn't matter what values you use for that, because you define how you interpolate over that as well as what you're animating it to. So you're welcome to use any range there. 0 to 1 is kind of a convention. I think a lot of people use that. So if you have these kind of animations that are static like this, you would often use that kind of range. So we can define other values from that animated value, or rather derive, and we can do that using the interpolate function. And that takes an input range, which is the range that the animated values kind of spans over, and then an output range, which is how you map that to some other output value. When the progress value updates, it then updates the interpolated value, and then the views that are bound to that value are then updated. And they're actually updated without doing set state. It's an efficient, more efficient update mechanism than that in most cases. And so that's one of the benefits of using this library. And so we can drive updates to the progress value by using functions like animated.timing. And we'll see a couple more that we can use as well. So this is the time for us to do our first exercise. We're going to scale a view. So we're going to just create like a simple box. You could give it red background color or whatever you want. And similar to the code that we just saw, we want to, as soon as it mounts, just animate it, animate some progress value from 0 to 1, and do any arbitrary scale that you want on that. So I'm going to leave this up here because it kind of reminds you of how these things work, and we'll just spend, hopefully everyone will get And if you're not completely lost, if you have questions, also just put your hand up, and we have people circling around. Okay, I'm just going to take a moment to talk about the syntax for transforms. It seems like a few people haven't done transforms with React Native before, and the syntax for it is pretty strange. But it does make sense once you understand why it's like that. So let me just explain it quickly. Okay, so if I have this text here and I want to give it some scale, so I'm just going to create an array here. Is that legible? There we go. So if I want to add a transform here for scale, first this is hopefully familiar syntax for people where I have an array. The first one is like some predefined style, and then this second one here is just the inline style. And transform takes an array, and it's an array of transform objects. So there's a lot of braces here, which often, hopefully you have an editor plugin for that, or you can look and see like as it highlights the beginning of the brace in Snack at least, so you can like kind of tell if you're doing it right or not. Anyhow, so actually it's also useful. There's prettier built into Snack, so you can just press this button and it'll format it for you. But to apply a scale here, right, we can do that. So, or whatever scale value you want. So I'm just going to format this a bit more legible. And then if I wanted to do like translate x, right, then that would be a different thing. And the reason why it's an array is that the ordering of these matters. If I do translate x before scale, it has a different impact on what you see in the result. It's a translate after the scale versus a translate before the scale. So that's why it's an array, basically. Anyone have any questions about transform? All right. So in the case of this being an animated value, it'd be like some value there for scale, let's say. Okay, I'm going to go back to this exercise quickly again. How many people are still trying to figure this out, trying to get it running? Yeah. Okay, great. So put your hand up if you have any questions. Let's work through this one so we can move on to some more interesting stuff with animations, because there's a lot more still to cover. Yeah. Take like 5 minutes to just grab some coffee, and then we'll move on and hopefully pick up the pace a little bit. There's a lot to cover for animation still. But if you're unsure about anything still at this point, definitely let us know as people are walking around, and we'll help clarify that. But yeah, we're going to move on after the break. So 5 minutes, just come back at 11, and we'll continue. Hey, how's it going? Yeah. And it's an hour. No, I didn't go to it. Couldn't make it. Did you go?
I did, yeah. I saw you there, but I'm used to it.
Yeah, right. Nice to meet you. So, you colleagues of use?
Used, yeah.
Okay.
I'm from
So for people who are here already, 3 minutes after we were going to resume, you can check out the link to the solution for the first exercise in Slack. I just posted a link to the snack for it, and we'll look at that really quickly and then move on. For future exercises, we're going to move through them a bit more quickly, and if you don't have time to finish it, that's fine. I'll share the solution for all of them in Slack so you can follow along that way. Oops. All right, I'm going to quickly walk through the first solution. So I'm just going to create a new snack here, get rid of this stuff. Is that legible? There we go. So first thing we need to do, import animated. And I'm going to replace this with a box style. I'll just give it a width of 50 and a height of 50, background color, red, and let's resize this so we can see it at the same time. Okay, so we have a little box on the screen. Good. Now we can create this animated value. Right. And component did mount. We'll add something there in a moment. But now let's jump down here and define how this progress value maps to scale. So I'm going to say scale this.progress.interpolate. Notice this tripped people up a little bit. So when you define instance properties like this, you access it in the render function or elsewhere on the component using this. So this.progress.interpolate, input value 0 to 1, input range, and output range of, let's go like that, just some arbitrary scales. And now to add this down here, transform, scale, and I just used the shorthand here. We could do scale, but a lot of you probably already know there's this thing called punting. So if you just, or is it punting? I think it's called punting. Where you can just use this shorthand where if the variable name is the same as the key in an object, then you don't have to do this full way of defining that. Okay, so we have this box. It's mapping to this value. We know that the animated value is at 0 currently, so it starts at this initial thing. So, right, notice that as I change it, it's updating. Now we want to start the animation. So timing, this.progress to value 1, and we could say duration 1,000. So notice that it still doesn't do anything, and that's because we need to call start on the animation, and there you go, it grows and does the thing. Something that I saw that tripped up a couple of people was that you need to pass in the animated value as the first argument for the timing function. So something to keep in mind there. The signature for it is you have in the first argument the value that you're operating on, and then the second argument is an object where you define the properties of how the animation works. So the link for this example, again, is in Snack here. So if you just go to react.eu.xyz and click on the link that says join the Slack, you can sign up and get it there. Okay, moving on. So just to give you a little bit of understanding of what's happening here when we bind to these values. So the reason why animated exports things like view, so view is just one of the components that's exported. There's scroll view, there's text, kind of like the core React Native components are available on the animated namespace. And basically all that happens, like all that animated is doing when it re-exports these is it's calling this function called create animated component, and then calling that with the view component, and then returning the return value of that. So it's a higher order component that wraps the view and knows how to handle these animated props. So how this actually works is you could actually create your own component that accepts any arbitrary animated props and still works as you would expect, but it won't have the same optimization that I mentioned before, where when you're animating the scale on a view here, it's not actually re-rendering the view. It's using this thing called set native props, which behind the scenes is kind of like directly manipulating a DOM node in the browser. You're just setting these properties directly on the underlying view. And so this allows us to get around how reconciliation, when you have to do it 60 times a second, can potentially cause performance problems. So if you do create your own animated component, keep in mind that unless it's a native component like view or text or that kind of thing that implements set native props, then it'll basically just call force update on the component for you and re-render every time the value changes. So animated has a few key ideas to kind of map out. So we have values, right? So this is like, as you've seen, a container for a number that forms this basis of the animation, right? We can interpolate values or interpolate a range of input values to output values on top of an animated value. We have components, which we saw with view before, and like I said, we have things like text and scroll view and other React Native components that are exported from the animated namespace that you can also use in that case. We have static drivers, so we've seen so far that animated.timing is one way to drive an animation, right? We can give it an animated value and start a animation on it, and that's kind of referred to as a driver for the animation. It's the thing that takes it and moves you firing a static driver that updates every frame. Event drivers will be in response to something like a scroll event or a pan gesture or that kind of thing. Then there are kind of two different ways for these drivers to work. There's something called the JavaScript driver. So this is basically all of the logic for the animation is being executed in JavaScript. And then there's the native driver, which serializes the configuration for your animation, and it executes entirely, after it's initialized, it executes entirely on the UI thread. And so I don't expect everyone to follow this now. I just want to like map out kind of the main things, and hopefully we'll have time to cover all of this, and it'll all become more clear. So we have all these things, and the way that it works, again, just to hammer this home, we have this animated value that contains a number. The component subscribes to updates on the value, and when the value updates, it sends that value over to the component. A driver is responsible for updating the value, and so we can see kind of how that flows from a driver that operates on a value that then updates components through some subscription to the value as it updates. It's very similar. Some of you did this during the first exercise. Rather than using Interpolate, you just bound the value directly to a property on the view. As we saw as well, you interpolate a value from the animated value and then bind the interpolation to the view. And this is also it's a very similar flow, except rather than the value directly updating the component subscribes to that interpolated value. And so the flow looks more like this, where it starts on the driver, goes to the value, interpolation updates, and then the interpolation updates all the subscribers. Okay, so we've seen so far that you can create, you can interpolate from a range of numbers to another range of numbers, but it's also possible to interpolate over strings. This only works for certain strings, so it'll only work if you have numbers in your strings. Perhaps you've used D3 before. This design was inspired by D3 and how you're able to interpolate colors and go from an RGBA value or from even a string like red or green to another one. And the kind of way that works is you're able to really convert any of these string values into actual numbers. You're able to convert the color red, the string red, into a numeric representation of the color. And then you're able to just treat that in the same way as if it were a number. So similarly, even in cases where like you can't do something like that, where it's clear that with green you convert that to some value and then animate between these two things. But if you have any string that has a number and any other arbitrary text in the string, animated knows to look for a number in both in the values in the output range and extracts the numbers and then replaces them inside of the string as it animates. So we'll see how that works in two ways. We're going to look at colors and rotation, which requires you to provide a unit of degrees or radians. So first exercise here for interpolating strings is we're going to rotate a view. So we can just take the example from before and change it from using scale to rotation, or rotate rather. And the output range should be in one of these forms. You're welcome to choose degrees or radians, whatever you prefer, and start from a value in the output range of some amount of degrees, and then go to another value of the same unit. So you can't go from let's say 2 minutes, it's pretty quick, and then we'll go over the solution really quickly and move on to interpolating colors. Okay, so let's have a look at the solution for this. So I can actually leave the scale transform in if I want. You can interpolate multiple values from a single animated value. So I'll do this .progress.interpolate. Do the same 0, 1. And output range, let's say 10 degrees to 500 degrees. And now if I apply this, that spins. Any questions about that?
How did they know that we used that?
Sorry, that.
Yeah, we didn't mention that we are going to use degree here. So are React Native parsing these strings?
Yeah, exactly. So in this case, it just ignores the fact that there's some other text in there and it replaces the number in place. So it's like, okay, you have a number here and you have a number here, and otherwise the strings are the same. So we'll just treat this as like number to number and work like that. Yep. Oh yeah, sorry. So the question was, how does React Native know that that we're going to be using degrees here? Like, how does it manage to understand that we are, when we say 10 degrees and 500 degrees, like, how is it able to identify the, like, how is it able to basically interpolate over this range? And it's just basically, it looks for numbers and replaces the numbers in place in the string. And the solution for that, I've just posted to Slack.
Can we do with pixels or other?
Yeah, you can use anything as long as there's a value that's accepted by a style property. Pixels, of course, don't make too much sense in the context of React Native, but yeah. So we're going to do another exercise now where we interpolate over colors. So here I'm just going to change the color from blue to white to red. And you'll notice there's a slight twist here in that so far we've just used an output range of having 2 different values, but you can have as many values as you want there. That said, you do need to provide the same amount of values in the input range as you use in the output range. So in this case, you might do something like 0, 0.5, and 1 in the input range. And then in the output range, you would have something like blue, white, and red. So another 2 minutes for this, and then we'll look at the solution. All right, let's look at the solution for this. We can, once again, use the same value. I'm just going to say background color, this, dot progress, dot interpolate. So I'm going to use 0, 0.5, and 1. Output range, blue, white, red. Once again, I need to actually apply this here. Right. And we can extend this a bit so we can see it more clearly. There we go. Any questions about that before we move on? So the key takeaway from that one is just that you can have multiple values in the input range and output range. And just keep in mind that they have to be the same number in the input and output range. And we could change this from 0 to 0.3, and it'll transition to white more quickly than it goes from white to red. And so you can kind of play with this to get different, accomplish different effects in your animations. And the link for the solution there is here. So sometimes you'll want to subscribe to the updates to an animated value. For various reasons that'll become clear when we look more at the native driver, we should not depend on being able to access the animated value synchronously. So you shouldn't expect to be able to say this.progress.getValue or that kind of thing, but rather you subscribe to updates, and then the value is passed into a callback, and then you can do what you need from that callback. And long story short, the reason why you shouldn't expect that is what I alluded to with native driver of executing the entire animation on the main thread or off the JavaScript thread. If it's executing on another thread, then the JavaScript thread won't always have the value, the current value for what the number that's held by the animated value. We can skip over this exercise because it's pretty trivial. We just add a listener to the animated value, and then we can do like set state on that. I'll post the solution if you're curious, but essentially that's all there is to it. Add a listener to the progress value, and then set state every time we get the value back. So if you're curious, the solution is right there. But in the interest of time, we will skip that. So sometimes it's also useful to be able to specify how we extrapolate from an input range and output range. So in this case, the default, so I've made it explicit here by saying extrapolate, extend, but the default behavior is extend. And what that means is if we had, although we've said the input range is 0 to 1, if the animated value was equal to 2, then the output would be 1,000 because it follows interpolating linearly over this range regardless of whether it's within the input range or not, and it just assumes that you would want to continue past that point. And so sometimes this isn't desirable and you want to lock the interpolated value to a given range. In that case, you can use clamp. So clamp does just that. If the value goes to 2, the output will be 500. If it goes to 1,000, it'll be 500. So it doesn't extrapolate beyond the range that's provided. Extrapolate left has the same behavior if the number is 2 or 3, right? It still is limited to 500. But if the value is -1, then the output would be -500. So it still extrapolates, but only on the left of the range. And similar kind of thing with extrapolate right. We're going to skip this one as well to move on to more interesting things. But hopefully that's clear. And, does anyone have any questions about this one before we move on? Yeah, pretty straightforward. So far we just looked at timing as a static driver for animations, but probably my favorite one to use is Spring. A lot of animations on mobile devices feel really good because they actually use some physics to, like some real physics formulas or approximations of real life physics to animate these values. And so when you just move linearly from 0 to 1 over 1 second, you increase the value by a consistent amount every time. And it kind of feels like dead and not like, doesn't really have like a good sort of feel to it. And it feels wrong, especially when it's in your hand and you're interacting with something in that kind of physical level. And so by using a spring, it gives a lot more of a feel of like the animation is kind of alive and it responds to you rather than just kind of doing its own thing over some set period of time. And as I mentioned before, the way that these static drivers work is every frame, they calculate some new value and then update the value, which is in contrast to event drivers, which we'll see later, where rather than every frame updating a value, it's every time there's an event, like a scroll, it'll update a value. So we can kind of visualize what this looks like. This is available in the animation and gestures example repository. It's under the visualization file. You can try it out if you want. But we can kind of see how in the graph there, we see how the animated value moves from 0 to 1. And linearly, right, it's just a straight line up. The slope of the line is consistent. But we can use different easing functions so that we know that this will execute in a certain period of time, but the value will change. It might, when the animation first starts, go a bit slower, and then towards the end, it'll slow down again. So it kind of accelerates and then decelerates. And that's what ease in, somehow open keyboard shortcuts. And that's how ease in out works. And it's also useful to see here, kind of when we turn on show frames, that the way that the individual frames are drawn here, the way that the box is moving, looks very different depending on whether it's this linear animation. So, right, you can see a concentration at the beginning and the end at ease in out quad because it accelerates, and then it's going fast in the middle of the animation, and then it decelerates again. And there you go. And linear, it's pretty consistent throughout. Any reasons, like any inconsistencies for why it's not exactly separated are related to the JavaScript thread blocking for maybe a frame or not running at 60 frames per second. This isn't the most optimized example, and so that can happen in some cases here. There's this useful site called easings.net, which if you want to get a sense for what these look like, and you can hover over the different lines and see as the value moves, get a feel for the animation curve. That's pretty helpful. And a lot of these are built into React Native, so you can import the easing module and pass in an easing to timing functions. So let's just take a second. I'll just do it right on here. Let's provide a couple of different easing functions to our current thing. So I'm going to import easing, and here, pass in easing, quad, and let's do it over a second. So it's pretty subtle, which is kind of why the visualization is a little bit more helpful to get a feel for it. But if you look carefully, you can notice that it does speed up. Like it starts off slower, accelerates, and then it kind of goes pretty fast in the middle and then slows down again. It sort of starts rotating a little bit more slowly at the end. So that gives it like quite a bit of a better feel than if I just switch to linear. Right, it kind of felt like a little bit, I don't know, a little bit unnatural, yeah. And these little things make a difference in your UIs. So just know that this exists. If you're using timing functions and something doesn't feel right with your animation, you can just try out these different easing curves and you might be able to get it to feel a little bit better by doing that. But often you'll probably use spring physics animations because it kind of feels like a cheat code for animations, honestly. You just use spring on an animated value, and it just feels a lot better a lot of the time. And you can further tweak the behavior of the spring animations by using different properties like friction and tension and speed and bounce. There are some other spring configuration options like velocity, which, velocity, I don't know how to explain it exactly. Overshoot clamping is kind of a really useful one. So the way that a spring works, if you think of like pulling a spring and then releasing it, right? It's kind of going to like, sort of like go in and then kind of bounce out. And maybe it'll sort of go beyond like the natural like settled width of it, right? If you have a spring and it's sort of coiled up, it's going to be a certain length, but when it bounces, it'll kind of exceed that length. And sometimes that's not desirable in an animation. Often if you're like animating a screen in, for example, if it overshoots so that you're able to, like if you're animating it from the side over, if it overshoots the destination, then you kind of see some extra space on the other side, and it just sort of looks a little bit strange. So keep in mind that this option's available, pretty helpful. And then there's these other properties called rest displacement threshold and rest speed threshold, which are useful for firing callbacks when an animation completes, which we'll look at very soon. So let's look at the spring effect there. So you can kind of see, like, as I mentioned of overshooting, notice how it's actually going off the screen. And the reason why this y-axis goes up to, I put it up to 1.4 here, is just that the value, even though I'm animating it to the value of 1, it actually overshoots to all the way up to 1.4 and kind of oscillates around that before settling at 1. And you can kind of see as well when we look at the frames just how it moves really fast at the start, and then at the end, right, it's oscillating a lot around that final point before settling. So this one's worth taking a moment to play with. We can go ahead and just change in our existing exercise that we have on our machines, change from timing to spring, and then just play around with these different models. We'll take a few minutes to do this, and you can set the friction and tension. I personally often use speed and bounciness because that's a very simple way for people who are not like people who know a lot about physics. Speed is a clear concept of what that is, and bounciness, I mean, it's very, very clear as well, versus something like stiffing or stiffness, damping, and mass. If someone can define those here, I'd be surprised. So yeah, give that a try. I would recommend playing with speed and bounciness and kind of see what that does to your animation. If anyone has questions, I'm right here, or put your hand up, and we have people walking around. Right, exactly. So the question was, we don't need duration when we use spring, and that's correct. When you use a spring, you specify these parameters, and the duration is just dependent on the parameters. You actually cannot specify a duration. So if you know that your animation should only last 200 milliseconds, if you're like scheduling something according to that, then you probably should use a timing function for that. Yeah, like React Motion. So React Motion is a library that's based around springs as well. Yeah. All right. So you probably have something that maybe looks something like this. And now we could tweak that to be, well, in that case, that was not, I think that reached the limit of bounciness. You can set the speed going into it and it sort of looks silly.
Is there a way to stop in one critical moment if that's with event?
So is there a way to stop an animation, was the question? Yep, we're actually going to look at that right now. So the way, if you want to stop an animation explicitly and just do, like, stop it exactly where it is in the animation, don't do anything else with it, there is something called stop animation. So this is one way to do it. Another way is you can actually just set the value directly. So you could say, like, this.progress.setValue, and any animation that's running on that animated value will stop. Or you can start another animation on that value, and that will also stop the animation. So I'm going to skip this one as well, since we had a little bit of a slow start, but I'll paste the link to the exercise in Slack, and or the snack solution in Slack, and you guys can have a look at that if you want. So the next thing that's worth covering is completion callbacks. So animations are usually things that transition from one thing to another, whether it's something being closed and then being open, or a new screen becoming visible, or maybe all sorts of things like toggling between states. And in order to often, I guess, do something when the animation completes, you need to know, I guess, when it happens, right? I mean, if you're using a spring, you don't know that it's going to take 200 milliseconds or 300 milliseconds or whatever. You would like for the animation to tell you, I am done. And it's a little bit tricky sometimes with springs. As we saw, it can bounce and sort of oscillate around a value for a long time before settling. I think the term is acquiesce. And so this completion callback only fires when it is completely settled. So if we look at this example here again, right, like it's like moving still very small amounts. And often the value will be almost, the amount that it's moving by will be almost imperceptible. So there are special considerations in the case of Spring for how to do this. And that goes back to these properties that I mentioned before of rest displacement threshold and rest speed threshold. So you can define in the animation for at what speed or at what displacement from the to value the animation is considered to be at rest or complete. So the way that completion callbacks work is essentially you pass in a function to the start function. So you just pass in this callback. The callback has a single parameter. The parameter is an object that currently only has one property on it, and that property is finished. So the reason why finished is passed in is because it's possible for animations, as we just saw, to be canceled or to be interrupted. And so if I were to start dismissing some part of, let's say I were to start maybe opening a screen and then I pressed another button like the back button, and so that was going to be canceled, the callback that I would fire when it completes would need to know, is this actually finished? Should I perform the action as if this is successfully completed, or should I just ignore it because it was canceled? And so that's essentially what this finished callback is for. As I mentioned here in one of the bottom bullet point is that often, right, animations will do something like block interactivity. So if you're dismissing a modal, let's say, and you animate out the background or something, you fade out a black background that's overlaying content, and once it's done, you set pointer events to none so that you can tap on the content underneath it. If you don't do that in a timely fashion, it's going to be really annoying that you can't interact with the screen. And so this is definitely an important concept to consider. And if we have time later, we're going to look into building a modal, so it's something to keep in mind. So let's play around with observing completion on the springs. We can just use the example that we had before, where we were just playing with springs, and let's pass in a callback, and when it completes, we can just fire an alert or do whatever we like at that point. And so you can kind of play with bounciness and just play with rest speed threshold in this case. You can play with displacement as well if you want, and just change it to whatever values and kind of see how that impacts when the callback is fired. And I'll leave this up here so you can see the syntax for adding a completion callback. Okay, let's have a look at how this works. So in this solution, I'll paste this over here. I mean, it's not really a solution, I suppose. It's just kind of a way to play with this. But I've added a listener to the progress, and I just output it here so we can see as it's moving, right? It's still kind of moving around for a while, and then it settles. And if we compare that to like timing, oh, this one actually doesn't have a completion callback on it. So it's animating to a random value here, which is why sometimes it's extremely fast. But you can see that by reducing the bounciness of the animation, it settles a lot more quickly. And also because I've changed the speed threshold to 0.5 rather than 0.1, which is the default. We could set the bounciness to 30. So you can kind of play with that. It's not really, I mean, I guess it is technically an exact science, but you're probably not going to learn it to that level where you're familiar with the actual physics behind it. So often you just end up playing with the value until you get something that works for your specific animation. And we could see also how this works when I stop, right? Interrupt it. Immediately it calls the completion callback, and finish is false. And so the animation is interrupted. Right, set value interrupts it as well. Okay, let's move on. So we don't have a lot of time. I think we have, is it 5 minutes? Yeah, 5 minutes before lunch. Sorry, yep, question. Well, the callback won't fire. So the question was, finish won't have any value until it's canceled or finished. But yeah, the callback doesn't fire until the animation has stopped, whether it's because it was canceled or because it was finished. So the question was, is it possible to pause and then continue the animation? And yeah, you can do that by stopping the animation and then firing the animation again. But it will, I guess, not be exactly the same. So not in the definition of like pause and then resume exactly where you were before. But it will pause it at the, you could stop it at a certain value and then animate it from that value to the end value again. I think they're usually, I can't really think of cases where I would have wanted to pause. Usually you would want to, like if you stop it, you would want to resume by restarting the animation, but from the value that you stopped at. Otherwise, you would feel like in the middle of an animation, right? Like if you were using a timing animation and it was using an ease in, ease out easing, and you paused it and then resumed right in the middle, then it wouldn't ease in. It would pick up exactly where, like, let's say the speed was beforehand. And I guess that's not. It's an interesting question. I'd be curious how to implement that with this. Okay, so before the break, we're going to talk about, really quickly, composing animations. So we can essentially use one of these, or as many really of these composing functions as we like. We can nest them to any extent that we want. So the most I guess basic one to think of is sequence. So all it does is executes the first one. When the first animation in the sequence completes, it executes the second one, and so on. And loop will execute the animations in sequence, but then once the last one completes, it'll go back and execute the first one again. And you could specify parameters for that, like how many times it should loop, or if it should loop forever. Parallel will execute all of them at the same time. And then one thing worth noting about this as well is that we call start on the outermost driver of the animation. So we're calling start on the sequence, the result from the sequence function, and not on spring inside of the sequence. And so the callback fires when the entire sequence completes, and you don't listen to the call to when the individual items in the sequence complete. And stagger, sometimes you'll want to execute an animation and then 100 milliseconds later or something, start this other part of it. And so that just allows you to do that. And yeah, like I mentioned, you can compose functions. So you could have a loop that has a sequence that is made up of some parallel animations all the way down as deep as you'd like. You're welcome to do this exercise over the break. I want to squeeze in with the remaining 2 minutes another topic, but I'll paste the solution for this in Slack as well for doing a loop with a sequence of animations. So this one kind of bends your brain a little bit, this concept in animated called tracking. So far we've seen animating to a static value, right? We'd say like animated spring, this dot progress to value 1, right? But you can actually animate an animated value to another animated value. So you can kind of chain things together. And then so in this case, as animated value, actually that's reversed. It should be as other animated value changes, animated value in this example will spring towards it. And so this allows you to create, maybe if you've used Messenger on Android, there's this like chat head kind of thing, whereas you drag it around, the various heads for the conversations that you have open all follow behind the finger. And so those use this kind of concept of everything kind of springs towards the one before it. This one is definitely worth doing an exercise over, but I just wanted to fit it in before lunch because it's kind of a concept that I want to mention again afterwards, and when we do the exercise, it'll hopefully become clear. But this lets you do some really neat things, and yeah, we'll have a look at that after the break along with using native driver. And then we'll move on in the afternoon to talking about GL React, which is applying OpenGL to React Native, and also it works on the web as well, universal components, which is another topic that we'll cover in the afternoon. So yeah, I'll see you, I guess, in an hour. Thanks.